Hello and welcome to the lesson from Monday, March 8th. Um, Today we're going to be talking about where we're going this week and some different ideas as far as some different things that we're going to be doing as far as writing equations of lines. That's our big goal for the week. Okay. It is going to get pretty interesting as we get going. The problems do definitely elevate from day to day, so bear with me, and we will give it a shot and try to take it one step at a time. That's really my goal. So let's get right into it. So today, the first thing I want to talk about is that we really need to remember that slope-intercept form is in the form y equals mx plus b. And it is important to remember, what are we looking at here? Okay, we're looking at a line. This equation would graph a line that has a constant slope, a constant rate of change, and then goes through the y-axis at a specific point. Okay, and in this, we need to find our slope, and we need to find our y-intercept. Okay, those are the two things that we need to find. Those are our slope and our y-intercept, because y and x are going to be in almost every one of these equations as just stagnant variables. Okay, that seems like an oxymoron. It seems like I'm saying two things that are opposites of each other. Just in the fact that those two physical letters are going to be in just about every equation that we come across. Because in order to have basically a two-dimensional equation, anything with any kind of slope, anything that's not straight horizontal or not straight vertical, we need those two variables to dictate that. Okay, if there's only one variable involved, the line is either going to be horizontal or vertical. So that's the only time that we're not going to have both y and x in our equation. So that being said, it's kind of a good thing, kind of a bad thing, that the only thing we have to find, the only two things that we have to find, are the slope and the y-intercept. Those are the two pieces of information that we have to gather from whatever is presented to us. And if you looked at all those lists of things that we're going through every day of the week, I'm giving you that information, and I'm slowly taking that information away from you, making you find it. Okay, but personally, I like to start visually. I'm a very visual learner. And so I start with my fellow visual learners, and we sort of build on it from there. So if I'm looking at a graph, I can write its equation. All I have to do is find the slope and find the y-intercept. Okay. To find the slope on a graph, I need to find 2 points, two good, what we call lattice points, where they have integer coordinates, whole number coordinates. So I'm looking for those, so that I can calculate my rise and my run. The other thing I also need is I need to find my y-intercept. Now, I will be honest in saying that typically I start off by finding the y-intercept. Okay, so like on this first one, I'm going to go ahead and make the claim that this is going through the y-axis at 3. Okay, so it has a y-intercept of 3. Now I need to find another point, another good lattice point on my graph. And I don't think that there's any to the right of 3. And I know that feels like upwards of 3, but yeah, it is. It's up and right. But I try to look right of 3 first, right of my y-intercept. I don't have any, so I do have to look left. So as I move left, now, yes, that's a severe drop on this line. As I move left, I still haven't found a good one of these intersections of a horizontal and a vertical grid point. I haven't found any, right? I haven't found a vertical grid line yet. I still haven't found one. I'm getting closer. I want to get to this -1 on the x-axis, and I'm hoping that that's going to give us a point. I haven't found one there. I think there's one right here. Now, I could argue that it does look like it misses it just in the slightest, but we're going to go with it. It's kind of the best we have, and it actually does cross right there. I know it's kind of hard to tell, but it does cross right there. So those are the 2 points that I'm going to use to find my slope. Notice I already know that my y-intercept, my b, is equal to 3. Okay, I already know that fact. That's where the line crosses the y-axis. Okay, now I just need to figure out my slope, and I just do that visually. I talk about, and you've heard me talk about it before, that I pretend I'm in an office building, and I'm down here to the left, and I have to go meet. I'm late for a meeting, and so I'm gonna take the elevator. How many stories, how many floors do I go up? And then how far down that hallway is that meeting place? So how many floors do I go up? I go up 1, 2, 3, 4, 5, 6. So I've gone up 6 floors, and I'm meeting people on the right, I guess. One door on the right, the first door on the right. So again, that's my analogy. I like it, but you do have to think about a pretty big office building to make that work. Okay, so we've gone up 6 floors and over 1 door. That means my slope is 6 over 1. My slope is 6 over 1. Or just 6 would work just fine. Okay, 6 divided by 1 is equal to 6, so that works. We want to write that equation. Y equals, remember, we're looking for y equals mx plus b. I want to put my slope in for m, my y-intercept in for b, and that's all we have to do. 6 was my slope times x. Don't forget that x. I always have students that forget that x because they just get in a hurry and you're just writing things and you write it really quick and you forget that x. And then plus 3. Okay, because my y-intercept was 3. So the 6 goes here, the 3 goes there, and we're done. That's that problem done. The next one, I'll do the same thing. I'll find my y-intercept. It's all the way up here at 5. But that's my b. My b value is 5. Now I need another point. Well, I can't go right any farther. That's off my graph. But I can go to the left, and I get a good point right there. That looks like the intersection of that kind of grid behind it. And I need to find my slope. So I start at the left point. I go up until I get on the same floor, and I go over. Looks like it goes up 1 and over 1. Well, that's not too bad. So my slope m is up 1, over 1, and that's just a slope of 1. 1 divided by 1 is 1. And so I write my equation in slope-intercept form. I want y equals my slope, which is 1, and you could choose whether or not to write that, 1x, and then my b is 5, so 1x plus 5. As I said, you can choose whether or not you want to write that 1, because 1 times x is still just going to be x. So that's the equation that we get. Oh boy, I got a lot of lines down here. Let's see. Yeah, just some other examples that I threw in there. Okay, good. Oh, still more there. Okay, but we'll get to those ones in a second. Let's focus on this one first. So I want my y-intercept. I want to start with that. That's right here at -4. So I could even write that. My y-intercept b is at -4. Now I need another point. Hey, look, I found one. I didn't have to look too hard. It was just the next point. And this one, again, has a slope of up 1 and over 1. So we'd say that the slope is 1. So my slope is 1. And again, I can choose whether to write it if my slope is 1. Because 1 times x is just going to be x. And my y-intercept is -4. Okay. As I start this next problem, I start the same way. I try to find my y-intercept. I don't have one. I do not have a y-intercept. That's because this is one of those special lines that's only going to have one variable because it's a vertical line. Okay? Horizontal and vertical lines, all I really do is I look at where are they located. Okay? This one intersects the x-axis, intercepts the x-axis at +1. And it turns out that every one of these coordinates have a 1 as their x-coordinate. It's 1, 4, and 1, 3. And maybe we go down here, 1, 0. Even down here, 1, -3. Notice what's always the same. The x value is always 1. That means the equation of this line is x is equal to 1. Okay? Vertical lines are written as x equals a number. Horizontal lines would make a little bit more sense. We will go over one of those so that I don't feel like I leave you up to chance here. Let's look at this one right here. So I have a horizontal line. Now, if I were to try to do this the way that I did the other problems, I would actually be successful. If I said, all right, find the y-intercept. The y-intercept is at -4. B equals -4. And then find the next point to the right. Well, look, there's one right here. This is a good point. It works just as good as any of the other ones. And how do I get to that point? How far up do I go? Well, I go up 0, but I do go over 1. I go up 0 and over 1. Well, that number as a fraction is 0 over 1, but as a whole number, 0 divided by anything is 0. So it has a slope of 0. Now, if I write that as y equals mx plus b, where the m is the slope and the b is the y-intercept, here's what I get. 0x, and then b is -4. And then 0 times anything is just 0, so this is really just y equals -4. But notice how, sorry about that, notice how it does actually work out to think about what's your y-intercept, find another point, what's your slope. So that way still works, but it just ended up that y-intercept was actually the entirety of my equation, to just say that y equals -4. Okay, so this y equals -4 is this line, if you're wanting to take notes on this, and your x equals +1 is this line. Those are two special cases of problems like these, but they're important to talk about. Okay, that's actually in the next video. So I'm going to go ahead and end it there. If this video helps you, that's awesome. Otherwise, feel free to send me an email and try to get more clarification on what we're doing. That being said, have a good day, and we'll see you in class.